Welcome back. We've been talking about piecewise functions, and in this video I want to talk about how the graph of a piecewise function relates to the graphs of the constituent pieces. In this example, I've gone ahead and picked pieces that you probably already know what the graph looks like. So x squared looks like that. X looks like this. And 6 looks like that. It is a horizontal line. So the question is, how do these three things get mushed together into one graph of a function? And I can't just stick them on top of each other. It doesn't work out quite like that. And the answer is basically that I need to look at this list of rules over here that tell me which graph to use. So when I sit down to try and sketch a graph of this, I maybe start over here on the left. And over on the left, the first line tells me I'm going to use the graph of x squared. I'm going to use the graph of x squared. It tells me up until the input -1. So I'm going to go ahead and put -1 here on the graph. And so I'm going to have something that looks like that. Again, this is a parabola. It's this piece of this parabola. That's where that came from. Then the second line tells me that for inputs between -1 and 6, I'm supposed to use the graph of x. Okay, so there's -1, so 6 is somewhere over like that. Okay, and so the graph of x from 1 to 6 will look something like that. Now, there's a small piece of information that we've omitted here. Namely, my graph doesn't currently give me a clear indication of what happens at -1. And so the way we're going to indicate that is by using open dots and closed dots. Okay. So at -1, I'm supposed to get x squared. So I'm supposed to use this graph, the red one. Okay. And to indicate that, I put here a closed dot. Whereas at -1, I am not supposed to use this graph. And to indicate that, I put an open dot there like that. Solid dot means use this point at this input. Open dot means don't use this point at this input. Last piece here is the graph of 6, which I'm supposed to use from here on. And I have to take a second to think about whether 6 is above this point. That is, should the line start up here, or below it? Should the line start down here? And so to do that, I want to look at what this point actually is. That is, at the end of the blue line, I have an x-coordinate of 6. What's the y-coordinate? Well, the function here is x. So the y-coordinate here is, in fact, 6. So that means actually the line that this becomes, it actually starts at exactly this point. Because the y-coordinate here is already 6, so when I go to graph in y equals 6, it just continues on from there. Okay, and so we grab that piece of the graph. Notice two rather different things happened at this point when we put those two pieces together, and at this point when we put these two pieces together. In fact, you could argue we did a much better job of putting the pieces together here than we did over here. Okay, and we have a word for this, namely our word for this is continuous. So if, when we get to a boundary in our piecewise function, the left side and the right side overlap, that is, they give you the same point and they meet up exactly like this, we call that continuous. Whereas if you look at the left gap over here at -1, there was this jump, and so this is discontinuous. Okay, or you will sometimes hear the term jump discontinuity. Because there is a jump in the graph. When you've heard the word continuity or continuous before, probably it's been something about like being able to draw the graph without picking up your pencil, and this is exactly that. Whereas here I could not draw this without picking up my pencil, which is why this is continuous, this is not. For our last question about piecewise functions, I want to go the other way. Namely, I want to start with this graph, which is made up of 3 lines. And my question is, how do we write a piecewise function whose graph would be this? So the first thing I think you want to do when you're figuring out how to write a piecewise function for something you're looking at is what the pieces are. That is, you want to figure out this side of things. And so the pieces in this case happen to break at the input -1 and the input 2. So if I call these pieces 1, 2, and 3, 1 is for x less than -1. 2 is for -1 less than x less than 2. Again, these are inputs I'm writing this in terms of, so I'm reading off that point and that point. And then 3 for x bigger than 2. Now, I did that a little bit fast, and this isn't quite right. Take a second, see if you can see what I'm missing. So what I'm missing is I didn't actually describe what happens at -1 and what happens at 2. Okay. Namely, when x is 2, currently I don't actually have a zone described. Which zone am I supposed to use when I have x is equal to 2? This is where this black dot, white dot thing comes in. I'm supposed to, at the input 2, use the black dot, meaning that I'm supposed to use the function that is given to me in section 2. Okay, that means I really need that. This extra blue slash turns this into -1 less than x less than or equal to 2. That finishes up that piece. What about over here? What do I need to do? Well, here actually something very different happens, and that's something that's very different that happens is that the function here is, as we said before, continuous. That means that if you use the left function, you would get the same answer as if you use the right function. I could use piece 1, or I could use piece 2. They'll both give me the same answer. And what that means is, you could actually put your or equals here, or put your or equals here, and both ways will give you exactly the same graph. So there is no way to choose which of these places to put in equals. They're both right. I'll choose that one. But if you chose the other, no problem. Okay, so what we've done so far is we've handled figuring out how we're going to sort out the inputs into the various pieces. That is, into piece 1, piece 2, and piece 3. What we have not at all spoken about, even a little bit so far, is how we're going to handle the outputs. And so now, I have to use the information provided to figure out what the outputs are in each of these pieces. So over here in zone 1, my function's given by a horizontal line. What horizontal line is it? Well, the point -1, -2 is on it, so it must be the horizontal line y equals -2. So this is now our output for zone 1 of our piecewise function. What about zone 2? Well, zone 2 is a line segment, and it's the line segment from -1, -2 up to 2, 0. So really, I need to find the equation of the line between -1, -2 and 2, 0. So the slope of that line will be 0 minus -2 divided by 2 minus -1, which happens to be 2/3. And so this is y equals 2/3 x plus b for some b. I'll go ahead and plug in 2, 0. So I will get 0 is equal to 2/3 times 2 plus b. So 0 is 4/3 plus b. So b is minus 4/3. And so that means my output for zone 2 is, in fact, y equals 2/3 x minus 4/3. Okay. Then I've got to handle 3. So 3 is, again, a line, this time from 2, -1 to 3, 2. And I'll note at this point, I'm only thinking about the outputs, so the fact that this is an open circle versus a closed circle, that no longer matters. I took care of all of that when I wrote down this piece just to start with. Okay, so I just need to find the equation of the line from 2 -1 to 3, 2. And so that'll be 2 minus -1 divided by 3 minus 2, which is 3 over 1, which is 3. So my equation looks like y equals 3x plus b. I'll plug in this 3, 2 point. So I'll get 2 is equal to 3 times 3 plus b. So 2 is 9 plus b. So b is -7. And so that means my output for section 3 is y equals 3x minus 7. So, then to write my answer, I just have to combine these 3 pieces of input with these 3 pieces of output. What's that going to look like? That's going to look like f of x equals... Okay, and so the output for 1 was -2. And then the input was x less than or equal to -1. Okay. Output for part 2 was 2/3 x minus 4/3. And that portion was relevant for -1 less than x less than or equal to 2. And our third output was 3x minus 7. And that was relevant for x bigger than 2. And so at the end of the day, this is our final answer to how we would write a piecewise function which gave us this graph. All right, That about wraps up the pre-calculus portion of this course. In the next video, I'm going to start talking about the motivation for calculus, what problem it is that calculus is trying to solve, and we'll begin figuring out what the tools are that we need to solve it. But that's all for now. I'll see you next time.